So in this video, we're going to talk about how to determine the zeros of a polynomial. So what I'm going to do in this video is I'm actually going to take everything that we've been learning in the last few lessons and tie it all together. So I just want to remind you that the zeros are the x values that make the function equal to 0. Remember that the zeros will tell you the x-intercepts of a function. So for example, we know that this function f of x equals x cubed plus 2x squared minus 5x plus 6 has zeros at x equals -3, x equals -1, and x equals 2, because that's the location of the three x-intercepts. Remember that the fundamental theorem of algebra tells us that the number of zeros is equal to the degree of the polynomial. So this is a third-degree polynomial. That's why it has three x-intercepts. Remember that you can find the zeros of a polynomial by setting it equal to 0, factoring, and then using the zero product property. So I just want to remind you that we do know how to find the zeros of a polynomial if it's already in factored form. So remember, the zeros are the values that we get when we set the function equal to 0. So for example, this f of x is already factored. So to figure out the zeros, we'd say that 0 equals x minus 2 times x plus 3 times 2x plus 1, right? And remember, the zero product property tells us that if we're multiplying some terms together and they equal 0, then that means that those terms have to be 0. So for example, this means that x minus 2 equals 0, or x plus 3 equals 0, or 2x plus 1 equals 0, right? Because that's the only way to multiply those binomials together and get 0. So now we can just solve these equations for x. So this first equation I would solve for x by adding 2 to both sides, and that gives me x equals 2. Okay, so that's one of my zeros. And then here I can solve by subtracting 3 from both sides, and that's going to give me x equals -3. So that's my second zero. And then my third zero, well, I'm going to need to first subtract 1 from both sides, and then that's going to give me 2x equals -1. And then I divide both sides by 2, and that's going to give me x equals -1/2. So that's my third zero. So we're going to take everything that we've been learning so far and tie it all together to determine the zeros of a polynomial. So remember, we're going to start off making sure that our polynomial is in standard form. Then we're going to determine the possible rational roots using the factors of the constant and the leading coefficient. Then we'll test our rational roots using synthetic substitution. If we find a rational root r that works, that means that x minus r is a factor of f of x. Then we'll write the depressed polynomial. And remember, if that depressed polynomial is a quadratic, we can factor it using those factoring methods that we discussed. Once we determine the other factors, we can write f of x in factored form. So all of these steps take us up to what we did in the last video. Today we're going to take it one more step further, and then we're going to set f of x equal to 0, and then use the zero product property to determine the zeros. So let's see what that looks like. So I'm going to take this example and completely work through everything that we've been talking about. So we want to determine the zeros of this polynomial. Okay, so it's obviously not in factored form, so I need to start off by determining the factors. So what I'm going to do is I'm going to start off by looking at the constant and the leading coefficient, and I'm going to determine the possible rational roots. Okay, so I'm going to make my list. Well, the factors of 6 are plus or minus 1, plus or minus 2, and plus or minus 3. The factors of 2 are plus or minus 1 and plus or minus 2. So now let's set up those fractions. So we have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, okay, and then plus or minus 1 over 2, plus or minus 2 over 2, and plus or minus 3 over 2. Okay, so 1 over 1, that's just plus or minus 1. 2 over 1 is plus or minus 2. 3 over 1 is plus or minus 3. Then we have plus or minus 1/2. Plus or minus 2 over 2 is plus or minus 1, so we don't need to write that again. And then we have plus or minus 3 over 2. So I know in the last video we were using Desmos, but I just want to show you how you'd use this without Desmos, okay? So if you were actually going to try synthetic substitution and see what works, I want to model that for you in this problem. So I'm going to start off with plus or minus 1, okay? So I'm going to do 1, and then I'm going to do synthetic substitution on this polynomial that I have. So I'm going to write out my coefficients, and so let's go ahead and substitute. Okay, so we bring down 2. 2 times 1 is 2. -3 plus 2 is -1. -1 times 1 is -1. -6 plus -1 is -7. Negative 7 times 1 is negative 7. 5 plus negative 7 is negative 2. Negative 2 times 1 is negative 2, and 6 plus negative 2 is 4, so we know that 1 does not work, okay? Because remember, this needs to be a 0 right here in order for our 1 to be a root. Well, since 1 didn't work, I'm just going to try negative 1, okay? So let's just try negative 1 and see if that's going to work. So I'm going to once again write out my coefficients. So I'm going to bring down 2. 2 times negative 1 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 5 times negative 1 is 5. Negative 6 plus 5 is negative 1. Negative 1 times negative 1 is 1. 5 plus 1 is 6. 6 times negative 1 is negative 6. And 6 plus negative 6 is 0. Okay, so x equals negative 1 is a root. So that means that x plus 1 is going to be a factor. Okay, so we finally determined one of our factors. So remember now, based on this, I can actually write the depressed polynomial. This is a 4th degree polynomial, so the depressed polynomial is going to have a highest degree term that's cubic. Okay, and that's going to have a coefficient of 2. And then we have minus 5x squared minus 1x plus 6. So now I'm going to take this depressed polynomial that I found and use the rational root theorem again, because it's a cubic polynomial, so I can't factor it using the methods that we discussed. So we're going to first figure out the possible roots. So remember, I'm going to look at the factors of the constant term. So I have plus or minus 1, plus or minus 2, and plus or minus 3. And then we look at the factors of the leading coefficient. So we have plus or minus 1 and plus or minus 2. So now let's form our fractions. So we have plus or minus 1 over 1, plus or minus 2 over 1, and plus or minus 3 over 1. And then when we use the second denominator, we have plus or minus 1 over 2, plus or minus 2 over 2, and plus or minus 3 over 2. So let's reduce these now. We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 1/2. Plus or minus 2 over 2 is plus or minus 1, so I don't need to write that again. And then we have plus or minus 3 over 2. So since I'm doing this problem by hand, I'm going to try out my possible roots starting with plus or minus 1. So if I try 1, I'm going to use the coefficients from this depressed polynomial. So I have 2, negative 5, negative 1, and 6. So I bring down 2. 1 times 2 is 2. Negative 5 plus 2 is negative 3. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 4 times 1 is negative 4, and 6 plus negative 4 is 2, so 1 is not going to work. Now let's try negative 1. So I'm going to do synthetic substitution again, and when I do this, I bring down 2. 2 times negative 1 is negative 2. Negative 5 plus negative 2 is negative 7. Negative 7 times negative 1 is 7. Negative 1 plus 7 is 6. 6 times negative 1 is negative 6, and 6 plus negative 6 is 0. So I once again have a root of x equals negative 1, which tells me that x plus 1 is a factor. So that x plus 1 is actually going to be a repeated factor when I write out my final answer. So now let's write the depressed polynomial. So this is a cubic that we've reduced to a quadratic. So it's going to be 2x squared minus 7x plus 6. So now what I need to do is I need to take this 2x squared minus 7x plus 6 and I need to factor it. So this is one of those trinomials where a is not equal to 1. So I'm going to look at a times c, which is 12. So now let's set up our factoring chart. So we're looking for factors of 12, and we need the sum of these factors to be negative 7. So let's list out the factors of 12. So we have 1 and 12. And we have 2 and 6, and 3 and 4. So let's look at this case. So we have 12, so both are going to have the same sign, and since 7 is negative, both are going to be negative. So we're going to make all of these factors negative and figure out the sums. So we have negative 1 plus negative 12, which is negative 13. Negative 2 plus negative 6 is negative 8, and negative 3 plus negative 4 is negative 7. So that's going to be the correct pair. So I'm going to expand this by writing 2x squared minus 3x minus 4x plus 6. So now I'm going to use factoring by grouping to put these terms into two groups and factor this. So I have plus negative 4x plus 6, And now what I need to do is figure out the GCF of the first group. So notice that we have a 2x squared minus 3x, so I can factor out an x. So I'm going to divide both of these terms by x. And when I do that, I get x times 2x squared over x is just 2x, minus 3x over x is going to be 3. All right, so let's go to the second set. So both of these have a common factor of 2, and since the 4x term is negative, I'm going to factor out a negative 2. So we have negative 4x over negative 2 plus 6 over negative 2. So that plus negative 2 I'm going to turn into a minus 2. So negative 4x over negative 2 is going to be positive 2x, and plus 6 over negative 2 is going to be minus 3. So I'm going to factor out the common binomial of 2x minus 3, and then do that times the outside terms, which are x minus 2. So let's collect all our factors and write f of x. So f of x is going to equal 2x minus 3 times x minus 2. Okay, and then remember from back here, we found this factor of x plus 1. And we have that x plus 1 that we found at the very beginning. So x plus 1 is going to be a factor that's written twice in our final answer. So remember that we can condense this, and this is going to become f of x equals x plus 1 squared times 2x minus 3 times x minus 2. So remember, in this problem, we're not actually trying to just factor, we're trying to figure out the zeros. So what we can do is we can set f of x equal to 0 and solve for the values of x that are zeros of the function. So here we've set up this problem, and remember that now we can use the zero product property, because if x plus 1 squared times 2x minus 3 times x minus 2 equals 0, that means that either x plus 1 squared equals 0, or 2x minus 3 equals 0, or x minus 2 equals 0. Okay, and we can solve these equations to figure out the values of x. So if x plus 1 squared equals 0, remember I can solve by first taking the square root of both sides. So that gives me x plus 1 equals, well, the square root of 0 is just 0. And now I can solve this equation for x by subtracting 1 from both sides. So when I do that, that gives me x equals negative 1, which is my first 0. And then I can solve 2x minus 3 by first adding 3 to both sides, and that gives me 2x equals 3. Now I can divide both sides by 2 to solve for x, so that gives me x equals 3 over 2. If you would prefer to do so, you can write this as a decimal, which is x equals 1.5. And now finally we can solve x minus 2 equals 0 by adding 2 to both sides, and that gives me x equals 2. So that is my third 0. So you may be wondering, well, didn't we start off with a quartic polynomial, right? It had a fourth degree, but why did we only find 3 zeros? Well, remember that this is a repeated factor, right? This x plus 1 squared. So it has a multiplicity of 2. So this x equals negative 1 is actually a root that has a multiplicity of 2. Okay, and so you can leave yourself a note there so that you know that we have 2 plus 1, which equals 4, which is the overall degree of our polynomial. So we're using the rational root theorem, synthetic substitution, and the zero product property, you can determine the zeros of a polynomial function. It's a lengthy process, but it allows you to solve polynomials without using technology.